Good morning, everyone. The topic that we are going to see today is graph theory. Let's see the basic definitions of graph theory. What is called a graph? A graph G is an ordered pair V, E where V consists of set of vertices and E is a set of edges. Now let's see with an example. So a graph G equal to V, E, where V is vertices and E is set of edges. So just see a square. So we know this is a square, but in terms of graph theory, here A, B, C, D, these are all the vertices and the edges are AB, BC, CD and DA. So this example is a graph with 4 vertices and 4 edges. So is it clear? Now a graph theory is an ordered pair of vertices and edges, right? So this example is a graph of 4, 4. That is, this graph consists of 4 vertices and 4 edges. Now let's see the next definition. What is called a loop? A loop is an edge whose endpoints are equal. That is, a line joining a point to itself is called a loop. A line joining a point to itself is called a loop. So here, this example, it is an example with a graph of 4 vertices and 4 edges. Now, what is the definition of a loop that we saw? Yes, it is a line joining a point to itself. So, for example, consider a line joining a point to itself. That is, a line is joining to the point A. So, here in this vertex, in this graph, this vertex A has a loop. So, this is a graph where we are having how many vertices and how many edges? Now, there are 4 vertices and 5 edges. So already we saw a graph with 4 vertices and 4 edges. Now we have included the loop also. So therefore this is a graph with 4 vertices and 5 edges. Now next definition. 2 or more edges joining the same pair of vertices is called multiple edges. 2 or more vertices joining the same one. So now consider the same graph again. So if I am joining an edge between B and C, already there is an edge between B and C. Now again I am joining one more edge. So now BC has how many edges? BC has 2 edges. So therefore this is called multiple edges. This is called multiple edges. And also you can say 2 vertices are adjacent if and only if there is an edge between these 2 vertices. For example, you can say here A and B is adjacent, A and D is adjacent, but what about A and C? A and C is not adjacent. Why it is not adjacent? Because there is no edge between A and C. Right. So this example is an example for a graph. It is an example for a loop, and also it is an example for multiple edges. But this graph is not a simple graph. Why it is not a simple graph? It means a graph is a simple graph if it has no loop and no multiple edges or parallel lines. So this graph we are having a loop. There is a loop here. The vertex A has a loop, and also the vertices B and C, there are multiple edges. That is, there are 2 edges between B and C. So therefore this is not an example for a simple graph. Is it clear? Right. Now let us see the next definition. Yes, simple graph. A graph with more than one edge between a pair of vertices is called a multiple graph, and A graph with loop is also called a pseudograph. So the graph which we have discussed, this is the graph. As I told you already, this is not a simple graph. Why it is not a simple graph? Because there is a loop and there is multiple edges. So, but this is a graph. This graph is an example for pseudograph. Now, what is the definition of a pseudograph? Pseudograph is a graph which contains loop and multiple edges. So, now this graph is a very good example for a pseudograph. Now, let's see the next definition. So, here, yes, what is a simple graph? Simple graph means a graph that has no edge, that has no multiple edges and no loops. That is a simple graph. And what is multigraph? Multigraph means it has multiple lines alone. It means there will be no loop. And what is a pseudograph? Pseudograph is that it has both loop and also multiple edges. Now, what is a directed graph? So far the graph we have discussed, it is not a directed graph, it is an undirected graph. It means, see, if we give an arrow mark here, if we give the direction, then it is called a directed graph. So now this is an example for a directed graph. If there is no arrow mark, then it is not a directed graph, right? Okay. And what is directed multigraph? It is again directed which has both loops as well as multiple lines. Now, okay. Now see, what is the definition of a complete graph? A graph is called a completed graph and it is denoted by Kn, which is a graph that contains an edge between every pair of distinct vertices. Every pair of distinct vertices. Now see, this is a graph. So let us draw a graph with 3 points. So A, B and C. A, B and C. So what is a complete graph is that it contains, that is, every pair of vertices is adjacent. So if I consider A and B, so in order to say that A and B is adjacent, there must be an edge between A and B. Similarly, there must be an edge between A and C and B and C. So we consider all the points of the graph, that is A, B, C, all the 3 vertices are adjacent to each other. So if I choose A, if I choose this vertex must be adjacent to the remaining 2 vertices. Similarly, if I choose this vertex, then it must be adjacent to the remaining 2 vertices. So again, if I choose C, then C is adjacent to A and B. So this is a complete graph. What is a complete graph? A complete graph, a graph is said to be a complete graph if every pair of its vertices are adjacent. So this complete graph, it is denoted by K3. It is denoted by K3. That is, in general, a complete graph is denoted by Kn, and here it is denoted, this is a graph with 3 points, so we are saying it as a K3. Now let us draw a complete graph K4, right? So K4 means I have to draw a graph with how many points? With 4 points. Let us name these vertices A, B, C and D. A, B, C and D. So if I consider A must be adjacent to the remaining vertices. So B, C and D. If I choose B, B is already adjacent to A. Now B must be adjacent to C, B must be adjacent to D. If I choose C, C is already adjacent to A, B and D. And D is adjacent to all the 3 vertices A, B, C. So this is a graph, this is a complete graph K4. This is a complete graph K4. Now, in general, what is the number of vertices in a complete graph and what is the number of edges in a complete graph? That is the question, right? So, the number of vertices here, it is 4. So, this is a graph K4, complete graph K4. So, therefore, you can just count out what is the number of vertices. Here, the number of vertices is 4. And let us see what is the number of edges. The number of edges is here, it is 6. Right? So now let us take next one, K5. So if we choose K5 means a graph with how many points? 5 points. So let us draw this K5. So let us name this A, B, C, D and E. So you can just count the number of vertices and number of edges. Here the number of vertices is 5 and the number of edges is 10. Okay, right. In general, what you can conclude is that a graph with n points, a complete graph with n points will have how many points? Will have n points. That is, it will have n vertices and how many edges? N into n minus 1 by 2 edges. N into n minus 1 by 2 edges. So, is it clear? A complete graph will have n points and n into n minus 1 by 2 edges. Now, let us see the next definition. What is a bipartite graph? A graph is called bipartite if its set of vertices can be partitioned into two disjoint sets V1 and V2 such that every edge in the graph has one point in V1 and the other point in V2. Now see here, just now we saw complete graph, now we are going to see bipartite. So let us consider, so this is V1 and V2. So I am dividing the whole vertex set into two sets V1 and V2, and every line, there is a line joining a point of V1 to a point of V2. So let us name this A, B, C and here D, E, F. If I consider A, there must be line from A to D, A to E and A to F. If I consider C, C to D, C to E, C to F. So this is an example for a bipartite graph, right? So there must be no edge connecting the vertices in the set V1 or connecting the vertices in V2. This is an example for a bipartite graph, and here for B, if I join the line, then this is an example for a complete bipartite graph. So a complete bipartite graph is denoted by Km, N. Km, N, and here the number of vertices will be M plus N. Number of vertices will be M plus N and number of edges will be M into N. Number of edges will be M into N. You can see the above example. You can just count the number of vertices. Here the number of vertices is 6. Number of vertices, because V1 and V2. If you add the vertices in V1 and V2, V1 contains 3 vertices and V2 contains 3 vertices. So 3 plus 3 is 6. And if you just count the number of edges in K3, 3, it is the total number of edges is 9 if you just count. And if we go with an example, that is if you go with the formula, it is Mn. So therefore it is 3 into 3, which is 9. Thank you.